Hello guys, this video is going over outward flux. So to kind of get some context of what outward flux is, or what they mean by the direction of outward, um, is that every time you're trying to find flux, it's it's going to be a vector in a certain direction. So if this is our flux, what you find it about is the counterclockwise direction. So if you ever use your right hand rule, that's where whatever direction your vector is, that's going to be your thumb, and then and I usually use the curve of my hand to show that what we find the circulation about, or the flux about. So in this case, when they say outward flux, they mean out of the page, and if it's out of the page, then that means that we stick our thumb upward and we see with the direction of our hand, and our hand is going counterclockwise. So that means we go counterclockwise as well about the points. So when we go around this wire, or this these equations, we have to go in a counterclockwise direction. And normally they'll give you the vectors, but in case that they as in the direction of which you would go, in the case that they don't, when they say find the outward flux, know that they mean go counterclockwise, because the vector that the flux is going is out of the page. All right, so and the normal equation for flux is equal to the integral, and they use this little circle because it means counterclockwise, some people may call it a surface integral, because it matters about the pathway you choose. And that's something we talk a lot about in Calc 3, are pathways that you take. And that's why, when we do limits, you take a different pathway, y equals x versus y equals x squared, and you go into the same point, but you get different values. That's because it's all dependent upon pathways. So that's why they use that counterclockwise circle, meaning both the direction, and it's showing that it's a path of which you're taking this integral of. And the equation, typically you do this for 2 dimensions, for this first unit at least, and it's m dy minus n dx. So, and this is the flipped version of circulation, where it's m dx plus n dy. But for flux, it's m dy minus n dx. I don't have any fancy way to remember it, but just note that you flip the dy's and dx's compared to circulation, and you change the sign from positive to negative. So if you remember one, then you can remember the other by knowing that these flip and the signs change. So to note, what the m and n is dependent upon your force. So m in this case is xy, and by this case n is xy as well, but m is for your I component, n is for your j component. I'm going to leave it as orange, green. So we need to figure out what y and dy is, and this is what they normally set it up for you to solve it in a certain way. Normally, because it makes it easier on the grader, and there's just a lot less things, like different things to expect to grade, because there's a bunch of different ways you can solve for the circulation for this, but they want you to do it a certain way. So, and then break it up into 2 pathways. So they want the circulation for all of C, but you have to go about C1 and add it to C2, because it's not the same equation all throughout the pathway. So for C1, they want us to do this all in terms of x, because they want us to solve for y and then plug it in. So and they'll prompt you as to what they want you to do. Again, they're the calc gods. They decide what goes into your equation. And this doesn't really change what the value you'd get for C1, but it just changes how they do it and how you would do it, and what things that the graders need to look out for. So for y, is just y equal to negative x, because that is our equation. Sometimes they may not be as direct as that. They might just say, they might just give you points and say, find out what this is. But just note that they just want you to solve for whatever that equation is. And then dy is just the derivative times whatever it is respect to. So normally you do dy dx, which would equal -1. But what they care about is that you multiply that dx to the other side. And sometimes it might be a dt, sometimes it might be a d theta, it might be something else. But just know that when they set it up for this dy here, they want you to solve for that. So in this case, take derivative of negative x, get -1, then multiply by with what the derivative is with respect to. So now all I have to do is plug in to our flux equation, which is the integral of m, which is xy, y then being negative x, times dy being negative dx, minus n, which is xy again, which is x times negative x, then times dx. Simplify it out. It will have x squared minus x squared times dx, which equals the integral of 0 dx. Which equals the integral of x squared plus x squared times dx. And we can simplify that down to integral So then you plug all of these into the flux equation. So even though our flux equation has this the circular on there, since we're only doing it for one part of the pathway, we just leave it as integral. So it's going to be the integral, and our points are for in terms of x. So we go from 0 to -1. Then we plug in for m dy minus n dx. So m being xy, so x times y being negative x, times dy, which equals negative dx, then minus n, which is x, times y, which is again negative x, times dx. Simplify that down, and it's the integral from 0 to -1 of x squared here plus x squared. So then it becomes 2x squared dx. So now we integrate. So it goes from 0. So we have to add 1 to our exponent. So it becomes, and then divide by the exponent. So 2 over 3 times x cubed, evaluated from 0 to -1, which then equals 2/3 times the -1 cubed, which is -1, minus 0, which equals -2/3. So that is what the flux is just across C1. But then we have to add that to our C2 to get the full flux evaluated across C. So now we need to evaluate C. So C is a little bit different. C is, with respect to, is essentially a circle. And whenever we deal with circles, they typically recommend that you solve for this in terms of theta. So if we remember with what all these values, x and y are in terms of theta, it's r and whatever the trig function is. So for x, it's r, which in this case is square root of 2, times cosine theta. And then dx would be the derivative of that. So I might need, yeah, that should be fine. It would be square root of 2 times negative sine theta d theta. And then y would be square root of 2 sine theta, while dy would just be square root of 2 cosine theta d theta. Again, we need these d thetas because we're taking the derivative of x and y with respect to theta. Because again, see our y equals a function of theta, x equals a function of theta, so we'll take the derivative, it has to be with respect to theta. And so then we have our d thetas for our dy and our dx. And it's just the same thing as the first time. Now we plug them in to our pathway for C2, and let's look at what our boundaries are. So our boundaries, again, so now it's going to be in terms of theta. So we have to just look. All right, so if this right here is 0 degrees or 2 pi, up top is pi over 2, and this is a 45-degree angle right here. So meaning that this is halfway between pi and pi over 2, so it's just going to be 3 pi over 4. And then we go all the way over to our third, and again, this is also 45 degrees, so it's going to be in between 3 pi over 2 and 2 pi, which is going to be 5 pi over 2. Wait. No, I'm going to be right. 5 pi over 4? 7 pi over 4. Because you have to add on pi. So we're going from 3 pi over 4 to 7 pi over 4 for mdy minus mdx. So m being, again, xy, which would, however, be 2, because again, it's square root 2 times square root 2 cosine theta times square root 2 sine theta. So you have 2 cosine theta sine theta. And then we have dy, which is square root 2. So I have 2 square root 2 cosine theta sine theta times cosine theta again, so this becomes cosine theta squared d theta minus 2 square root 2 because we're going to get the same thing, but instead of it being cosine squared, it's going to be sine squared theta d theta. Because again, we have our xy for cosine sine theta, and then our dx is actually just going to be a positive because we have a square root 2 minus sine theta d theta. So we plug that in as well for our dx, and that will give us this equation. Simplify it out. Integral from 3 pi over 4 to 7 pi over 4 of, I want to plot the 2 root 2 out front. You have cosine squared theta sine theta plus cosine theta sine squared theta all times by d theta. It's not too bad. We're going to have our u for the first part of this equation to be cosine, while du is sine theta. And we'll have u for the second part be sine theta, while du is cosine theta d theta. So it's like we pretty much have two there. We have u squared for both of these, and they're going to become u cubed with this different u. So again, like I said, for the first one, cosine, the third one, the second one is sine. So this will equal 2 root 2 times cosine, negative cosine cubed theta, because cosine, so because if u is cosine, du would have to be a negative sign, so you have a negative out there, plus sine cubed theta. This is all divided by 3 for each term, so I'm just going to pull it out. This is all evaluated again from 3 pi over 4 to 7 pi over 4. So then we have to evaluate it for each of these. So 2 square root 2 over 3 times negative cosine, negative cosine 7 pi over 4 cubed plus sine cubed of 7 pi over 4 cubed. Make that parentheses on the inside minus cosine cubed of 3 pi over 4 minus, plus sine cubed of 3 pi over 4. Okay, that looks pretty messy, but it's not too bad in terms of the algebra. We just need to figure out what 7 pi over 4 and 3 pi over 4 are for cosine and sine, then cube it. So for both, but there should all be the same value for sine and cosine, except for one's going to be a negative version of the other. So we're looking at the second quadrant. So it should be 2 over root 2. Sorry, negative 2 over root 2, 2 over root 2 for cosine, sine respectively, and then 2 over root 2, comma negative 2 over root 2 cosine and sine respectively, dependent upon the radian. So for the first one, so it'd be 2 square root 2 over 3 times some negative cosine 7 pi over 3. So that should be a negative 2 root 2 cubed plus 2 root 2, negative cubed, negative 2 root 2 cubed, then minus should be again a negative 2 root 2 cubed plus 2 root 2 cubed. So this is a lot. Okay, never mind. The algebra is not that easy. It looks all messy after actually putting it all out there. So let's see if I can get all this in one go and not have to add more space. So this becomes 8 over 2 root 2, so 4 over root 2. So it comes to negative 4 over root 2 minus 4 over root 2 minus a negative 4 over root 2, so it should be minus, so I'm going to leave this minus 2 over root 2, because that should go to so it should go to negative 4 over root 2, then it's negative, yeah, that's right, and then plus 2 over root 2, sorry, 4 over root 2, that's my bad. So you can cancel out these root 2's for all of these. Just distribute that root 2. And then I want to have a negative 8 minus negative 8. So I have minus 16. And then times by 2 and divide by 3. So negative 16 times 2 is negative 32 over 3, negative 32 over 3. And then this should equal negative 2 over 3 minus 32 over 3, which then equals negative 34 over 3. So then I'm able to say the whole pathway for flux of C will equal the first one, the integral C1 plus the integral C2, to get negative 34 over 3 for flux. All right, that should be it. I hope this is helpful in terms of setting up, but that's the majority of the problem, is trying to figure out what your is to set up is setting it up, and then doing the algebra and knowing which direction to go for your pathway. If you have any questions, please feel free to email me or comment below. Good luck on your test.